Flex rigid stack-ups are sometimes symmetrical across the diagonal. This presentation shows you how to accurately document this type of stack-up in Speedstack Flex. Here's a finished printout of a stack-up, and you can see on the left-hand side we present the bill of materials. These are the constituent parts of the stack-up shown in their layer number order. These are the parts you'll use to generate the finished stack-up. On the right-hand side, the first rigid section, which maybe includes a stiffener, then the flex, and then the second rigid section completes the stack-up. Here's how the completed edited stack would look in Speedstack. But we start off by building the bill of materials on the left-hand side, and this is the anchor for the finished stack-up that we're going to create. Here are the steps required to create the document I displayed in the previous slides. This first edit screen is actually the bill of materials that are going to be used in the final diagonally symmetrical stack. The next step is to open the navigator. So when I highlight this first left-hand stack, we can see it's the bill of materials. I'll copy this 4 times. First, second, third, fourth. For clarity, I'm going to put a space between the bill of materials on the left and the symmetrical stack that we want to document. The stack is created by first selecting this area we want the gap to appear and right-clicking in the editor area, selecting the Flex Rigid menu and toggling all the materials. This now hides all the materials and gives you a visual separation between the bill of materials and the stack that you're going to produce. I'll select the center of the flex now, and by holding down Control and selecting each material above the flex area, right click, Flex Rigid menu, and disable these materials. Repeat the process underneath, hold down Control, select all of the materials beneath the flex, right click, disable these materials. You can now see what looks like a fairly conventional flex stack to the right of the bill of materials. Now to display the diagonal symmetry, it's simply a case of, on the left hand side here, selecting the materials underneath the flex section, into the Flex Rigid, disable, and now repeat that process on the right hand substack, and this could be a connector on the top of the flex and a connector on the bottom with stiffeners or whatever selection of materials that are in your design. So I'll complete that now, hold down Control, select, get this right, let's select these on the top, so I'm going to deselect that. Select all the materials above the flex portion, right click, disable, and now you can see in the navigator the bill of materials, a gap for clarity. We can actually rename this intentionally blank. Rename this, and so on. Once you've reached this stage, it's very simple to go ahead and print a technical report. you can now see the bill of materials, intentionally blank, Flex 1, and then you can choose your own names for the right-hand side sections of the stack up. In this particular case, for clarity, I've left off any control impedance information or drilling information, but you can add that at a later date. It's important that when you build this type of stack that you ensure you get the bill of materials correct so that the copper layer numbering is identified before you start to build the substacks. Thank you for watching this brief presentation on documenting flex rigid stack-ups. If you'd like more information or a product demonstration, please do contact your local Polar office, and you can find your local Polar office contact details on the following screen.